Elon Musk has made major announcements about Tesla Robotaxi. It is already operating without supervision and driving autonomously on several routes. Elon Musk said that the self-driving Tesla taxi took him around Austin with no safety monitoring system in place. Musk has also previously stated that the core autonomous driving technology behind Robotaxi, FSD, is expected to officially launch in the Chinese market around February to March 2026. With the deadline approaching, it appears that Tesla is accelerating the rollout of Robotaxi in China. Recently, Tesla posted urgent Robotaxi job openings on its Chinese recruitment website, signaling that the company has ambitious plans for its Robotaxi program. In addition, Tesla has introduced a number of rules for Robotaxi passengers. Let's take a look at the latest updates right now. Even before entering mass production, Tesla's Cybercab has already begun reshaping the streets of Austin, with multiple prototypes recently spotted testing in the downtown area. Videos and images show sleek, two-seat autonomous vehicles navigating through traffic. Interestingly, these vehicles are equipped with temporary steering wheels and safety drivers. Over the past weekend, car enthusiasts captured footage of two Cybercabs driving side by side in downtown Austin, their futuristic design standing out among regular traffic. Although these vehicles currently feature temporary steering wheels and side mirrors, they still retain their original modern exterior design. As we can all see, the increased activity indicates that Tesla is intensifying testing of its two-seat autonomous vehicle ahead of its planned mass production. Elon Musk confirmed at the 2025 shareholders meeting that production is expected to begin around April 2026 with ambitious targets. In an all-hands meeting earlier this year, Musk also hinted that Tesla's factories could eventually be capable of producing one Cybercab every 10 seconds. Tesla is also refining how Robotaxi operates. We recently learned about several precautionary measures for passengers using Robotaxi, including age restrictions and cleaning fees. Specifically, to ensure interior cleanliness, Tesla has introduced a cleaning policy that charges $50 and $150 for moderate and severe messes, respectively. At this stage, if a passenger spills food, smokes, vomits, or causes serious interior contamination, they may be charged a maximum penalty of up to $150. In cases such as dropping French fries, tracking mud onto the floor mats, or situations where only vacuum cleaning is required, passengers will be charged $50. These measures not only help maintain a clean interior, but also help regulate passenger behavior, ensuring a comfortable experience for everyone. Finally, Tesla is actively developing wireless charging technology to provide a fully automated 24/7 charging solution for Robotaxi. Once launched, this technology will allow Robotaxi vehicles to complete the charging process without human intervention, achieving true operational autonomy. According to Elon Musk, the Tesla Cybercab Robotaxi will be the company's second biggest product next year. And recently, Tesla's stock has reached an all-time high as the company demonstrates that the Tesla Robotaxi can operate fully autonomously on public streets without a driver or a safety supervisor. There's only one vehicle on the road, and every driving decision is made entirely by AI. You know, one of the biggest breakthroughs of Robotaxi lies in Tesla's gradual removal of humans from the role of direct supervision. In the past, even though they were called self-driving cars, most systems still required a safety driver or a staff member inside the vehicle to intervene when something went wrong. This not only diluted the true meaning of autonomy, but also made scaling extremely expensive. Recently, Tesla has begun testing robotaxis that operate completely without human occupants on public roads, showing that the AI system has reached a level of reliability high enough to handle complex traffic situations on its own, without human assistance. At the core of this advancement is the artificial intelligence Tesla has developed for Robotaxi. Unlike many other autonomous vehicle companies such as Waymo, Tesla does not build its system around LiDAR, high-resolution static maps, or a dense array of expensive sensors. Instead, Tesla focuses on vision-based AI, using cameras and neural networks to see and understand the world in a way similar to how humans drive. This system not only recognizes objects, lanes, and traffic signs, but also learns to predict the behavior of surrounding vehicles and pedestrians, allowing it to make appropriate driving decisions in real time. But here's the key difference. The AI behind Tesla Robotaxi is not programmed around fixed scenarios. Instead, It's trained on an enormous volume of real-world data collected from millions of Tesla vehicles driving across the globe. Every traffic situation, every hard brake, every missed turn, and every unexpected maneuver becomes training data for the system. Over time, this allows Tesla Robotaxi to continuously improve its safety and decision-making accuracy, much like a human driver gaining experience with every mile driven. Compared to traditional autonomous vehicles, Tesla Robotaxi stands out most clearly in its scalability. Many self-driving systems today work well only within tightly restricted geographic areas, where roads are meticulously mapped and traffic conditions are relatively predictable. But once they move outside those safe zones, performance often drops sharply. Tesla is aiming for the opposite. A system that can operate anywhere a human can drive, from dense city centers to complex residential neighborhoods, without requiring special infrastructure or pre-mapped environments. Another major difference lies in Tesla's approach to hardware. While many companies must design a dedicated, purpose-built fleet for autonomy, Tesla leverages the same mass-produced consumer vehicles it already builds. That means not only the Cybercab, but even vehicles like the Model Y and Model 3 can potentially function as robotaxis. And Tesla's recent progress toward fully unsupervised in-vehicle operation strongly suggests that the company is close to solving the most critical challenge in autonomy: safety. As the primary vehicle designed for robotaxi use, mass production of the Cybercab is set to officially begin in the second quarter of 2026 at Giga, Texas, with some pilot production lines potentially starting as early as late 2025. The target price for the Cybercab is expected to be under $30,000, and Tesla aims to keep operating costs at around 20 cents per mile. Notably, the Cybercab will not include a physical charging port. Instead, it will autonomously drive to wireless charging pads at designated parking areas to recharge, allowing the robotaxi system to operate fully autonomously without human workers plugging in vehicles. Advances in Hardware 5 and FSD version 14 have significantly increased the reliability of robotaxi, addressing many of the concerns that have historically surrounded autonomous vehicles. Rather than focusing solely on removing the driver, Tesla is aiming to create an AI agent that can take responsibility for its own behavior on the road. This approach has the potential to reshape the entire urban transportation model, where vehicles don't just follow human commands, but actively optimize traffic flow, reduce accidents, and improve overall infrastructure efficiency. Okay, if Tesla Robotaxi is a wheeled robot that runs on the road, then people are also extremely interested in Tesla robots that will work indoors, robots with legs. Elon Musk has also always argued that Optimus even consumed more of the company's efforts than self-driving cars. There is nothing that can truly be compared to Optimus. The AI technology inside Optimus is even more advanced than anything found in Tesla's other products. And that's what gives Elon Musk the confidence to say Tesla could eventually sell billions of robots, to the point where Optimus becomes more common than smartphones.
So the scale of Optimus, like I said, that's really going to be something else. I think it's going to be the biggest product of all time by far. Yeah. So, like bigger than cell phones, bigger than anything.
We've known about the Tesla Bot project since 2021, but the truth is, it's only now that the concept of a humanoid robot is becoming truly clear. And that's simply because the speed of AI evolution is allowing these machines to reach a much higher level of intelligence. More accurately, they now have something that resembles a real brain. With Tesla Bot, Elon Musk says AI will no longer be trapped behind a screen. Instead, it will step into the physical world, using hands, using vision, using the entire body to work just like a human. And with that level of confidence in his robot, Elon Musk has made a statement that's been heavily debated recently. Optimus could eventually make human jobs optional. If you don't want to work, Tesla's robot could do the work for you. It's smart enough and dexterous enough to handle the same tasks you're doing today. And in Elon's words, it could ultimately make you wealthy.
AI and robotics continue to advance, which they are advancing very rapidly. Like I said, working will be optional, and people will have any goods and services that they want.
Elon Musk has emphasized that the complexity of Optimus is greater than any product Tesla has ever built, second only to Starship. And this is the key point. Optimus was not designed to do just one job. It's not a welding robot, not a warehouse robot, and not a show robot. It was developed as a general-purpose robot, capable of handling almost any task a human can do, roughly 80 out of 100 human jobs. Now, there are still some physical tasks it can't perform. Humans can lift extremely heavy objects, and Optimus may not match that raw strength. But when it comes to tasks that require dexterity, precision, and calculation, Optimus can already outperform humans. You know your brain can forget, but Tesla Bot doesn't. It learns far faster than any human ever could. From the very beginning, Elon Musk focused on the essence of human design when developing Optimus. That's why its size closely matches a human, 5 feet 10 inches tall, and about 140 pounds. Optimus does not use LiDAR sensors. Instead, it relies on 2D cameras similar to human eyes, combined with neural networks to perceive 3D space, recognize objects, and judge distance. The brain, located in the chest of the Tesla Bot, is a powerful chip designed in-house by Tesla. It processes billions of calculations per second, enabling real-time decision-making and movement control. Of course, Optimus doesn't perform tasks perfectly from day one. It has to be trained on basic actions like grasping, holding, and carrying objects. That may sound simple, but it requires an enormous amount of time and effort from the engineering team. To put it simply, just to teach Optimus how to hold a bag of popcorn, engineers trained it thousands of times in a virtual environment, refining the behavior until there were no errors left. Optimus is trained using the same core AI system Tesla uses for full self-driving. That means it learns how to see, understand, decide, and act in the chaotic conditions of the real world. Whether it's a factory, a home, a restaurant, or even a construction site, Optimus can be deployed in almost any environment. As we mentioned earlier, Optimus doesn't learn through step-by-step programming. It learns the way humans do, by observing, understanding, experimenting, and correcting mistakes. According to Elon Musk himself, Optimus can learn new tasks simply by watching videos, including regular YouTube videos or standard how-to guides. Just like humans learn how to cook, fix things, or clean the house, Optimus watches human actions in videos, extracts motion patterns, task sequences, and the final goal of the job. This is where the concept of task extensibility becomes incredibly powerful. In theory, Optimus can learn almost any task in a very short amount of time, without needing to be trained from scratch. And with the integration of large language models like Grok from XAI, Optimus won't just follow commands, it will understand context. For example, if you say, "I'm thirsty," it can infer that it should go get water, instead of waiting for a direct command like, "Go get me a drink." It may sound hard to believe, but take a look at how Tesla has built the brain of Optimus. Instead of using multiple separate AI systems for different tasks, Tesla relies on a single, unified neural network to control the entire robot. This AI processes camera vision, understands spoken or written language, plans movements, and controls the robot's body in three-dimensional space. It's the same philosophy Tesla uses for full self-driving in its vehicles. In recent demo videos, Optimus isn't just sweeping floors, cooking, using a microwave, or vacuuming. It's also working inside factories, picking up components, sorting parts, and placing them precisely on conveyor belts. What stands out is that Optimus doesn't need detailed instructions. With a simple command like "clean the floor," the robot can independently reason through the steps required to complete the task. Optimus can now work with both hands at the same time. In the past, most tasks were performed using just one hand to reduce complexity. But true two-handed coordination requires the AI system to process multiple data streams simultaneously: the position of the left hand, the right hand, overall body balance, collision avoidance, and smooth, real-time motion control. This alone shows that Tesla's control software and AI models have reached an entirely new level. And once the AI reaches full maturity, Optimus will take on roles directly inside Tesla's production lines at Giga Texas. These robots will help assemble other robots, what many people call machines building machines. Tesla is targeting the release of at least 10,000 Optimus units next year, with Optimus version 3 expected to launch in Q1. This will be the first true commercial version, with a level of refinement far beyond the version 2 and 2.5 models we see today. And at the end of today's video, let's briefly talk about the Tesla Semi, the truck that once seemed to be forgotten but is set to make a comeback next year with several major updates. With the latest Tesla Semi, the company has added an entirely new camera position, mounted just above the front wheel arch, a very clear signal that the Semi is being optimized for fully autonomous heavy truck operation. And if FSD is truly deployed on the Semi, it won't just be an upgrade. It will change everything.
I think ultimately we'll make over millions probably, of the Tesla Semi. This is really going to be something that you'll see all over the place. And it'll also be autonomous, or have the ability to go autonomous down the road.
Elon Musk has confirmed that full self-driving capability will soon be integrated into the latest version of the Tesla Semi, and the company is expected to begin testing autonomous Semi operations by the end of next year. Tesla's move to bring FSD to the Semi is widely seen as a response to the ongoing truck driver shortage in the United States, where harsh working conditions have made the job increasingly unattractive. With FSD, the Tesla Semi would be capable of self-driving on highways, reducing stress and fatigue-related accidents while also optimizing delivery schedules.
Okay, there's more people leaving truck driving as a profession than entering it. Well, we're going to have a real logistics problem as time goes by. So autonomy will be very important to meet that need.
We all know that long-haul trucking is facing an existential crisis. The severe driver shortage isn't just a staffing problem, it's the result of an outdated operating model. For decades, truck drivers have been forced to trade their physical and mental health for the job, spending endless hours in noisy cabins under intense delivery pressure and facing constant accident risks caused by fatigue. On average, the total number of tractor-trailer accidents in the United States each year is estimated to range from roughly 160,000 to 300,000 incidents, including minor crashes, serious injuries, and property damage-only accidents. And as Elon Musk has pointed out, more drivers are leaving the industry than entering it. That gap will only continue to widen unless a viable alternative to diesel trucking emerges. With its long-term vision, Tesla isn't just building a truck to replace diesel engines. It's rolling out an AI-driven ecosystem for a Class 8 truck, designed to free drivers from the most punishing aspects of the job. From our perspective, the arrival of the Tesla Semi combined with full autonomy through FSD could mark a historic turning point for the global logistics industry. Instead of gripping the steering wheel for thousands of miles, FSD allows the truck to operate smoothly on highways, transforming the driver from a manual labor into a technology supervisor. While AI handles repetitive tasks and manages traffic variables with extreme precision, the driver can rest, recover, and stay alert throughout the journey. Yeah, Tesla Semi has the potential to help businesses optimize operating costs, reduce human error, and ensure that the flow of goods never stops. This is the future of transportation, where technology doesn't replace humans, but elevates their value and safety to an entirely new level. Of course, integrating full self-driving into the Semi will come with serious challenges and require strict regulatory approval. After all, with a gross weight of up to 80,000 pounds, AI errors are no longer measured in centimeters, they're measured in human lives. But, the biggest challenge lies in vehicle dynamics. A massive machine with a braking distance far longer than a passenger car demands an FSD system with extremely long-range predictive capability. The AI must account for the inertia of the loaded trailer to avoid catastrophic scenarios like jackknifing during emergency maneuvers. On top of that, long-haul trucking often operates through data gray zones. From dense fog that degrades camera visibility to temporary construction sites where traffic is controlled by human hand signals. Okay, Tesla has launched the lower-priced Model Y standard, but it's not really cheap. And many people even think it's not worth the money at the $39,990 price point Elon Musk announced. Unless you really want to buy a Tesla, you might want to skip this option and wait for a vehicle that's expected to be about 25% cheaper, which is set to launch next year. This could be Elon Musk's backup plan in case Model Y standard sales don't meet expectations. With a wave of leaks coming out of Fremont, new activity from Chinese suppliers for this model, and changes within Tesla's structural casting program, the Model 2 or Model Q appears to be the hatchback Tesla has been missing. It's closer than ever, and it's expected to come in at around $30,000. If the leaks are accurate, this model could be extremely competitive in both the US and China. It may not be as refined as the Model Y or Model 3, but it will be Tesla's most transformative vehicle yet. So what exactly has been leaked about this car? Why is it so different? And what is Tesla's plan for the 2026 Model 2? Over the next 18 minutes, you'll see why this could become Tesla's next big success. Things are about to get very interesting.
We need to make sure that it works. This is some crazy, crazy technology.
Okay, for many years, Tesla has talked about releasing a new affordable $25,000 vehicle for the brand through statements from Elon Musk. But in the end, most people were left with a familiar feeling, much like when Tesla launched the Cybertruck. A vehicle that didn't live up to expectations, while the price was nearly double what people had hoped for. And yes, that's exactly the Model Y standard. Unsurprisingly, it hasn't sold very well, because customers can essentially spend about $5,000 more to get a Model Y Premium or a Model 3. Even lower-priced vehicles like the Chevrolet Equinox or the Toyota BZ offer similar or even better overall quality. Although we're Tesla fans, we've never really been impressed by the Model Y standard. From the moment it was announced, we predicted that it wouldn't meet customer expectations, especially with its stripped-down interior and limited features while still carrying a $40,000 price tag. We think it would have made far more sense to price this model at $35,000. That would have been much more reasonable. However, this isn't the last affordable vehicle Tesla plans to produce. There are still many other plans in motion, because it's clear that Tesla is steadily making cheaper EVs than in previous years, with more efficient new technologies being introduced into its production lines. And this is why we may soon be able to buy a new Tesla priced about 25% lower than the Model Y standard, with Tesla's Fremont factory in the US, set to be involved in producing this model. According to internal reports, the vehicle is expected to debut in May 2026, and Elon Musk has instructed Tesla team to finalize every detail, from design to specifications before the official launch. Even when Joe Rogan pressed Elon Musk to reveal information about this model, Musk said he couldn't say anything until it's officially announced. But the Tesla CEO believes this could be a truly unforgettable product.
I can't do the unveil before the unveil. I think it has a shot at being the most memorable product unveil ever. It has a shot.
As soon as the information was leaked, the Tesla watching community immediately split into two clearly opposing camps. One side is skeptical, believing that to hit the $30,000 price point, the Model 2 would be significantly worse, forced to make too many compromises in terms of comfort and overall user experience. On the other hand, many people are genuinely excited, especially customers who have been waiting for years for a truly affordable Tesla. For them, the Model 2 isn't just a new vehicle. It represents the doorway to owning a Tesla EV for the first time, even if that means accepting certain trade-offs. Although it hasn't been officially unveiled yet, leaks from inside the Giga Texas factory have already given us a glimpse of what's coming. While Elon Musk has not confirmed the official name of this model, the name Model 2 has long been considered the most fitting. After all, when you line up Tesla's 4 existing models, you get double sexy. Sounds interesting, right? Of course, there are still some groups who believe it will be called the Model Q. Okay, Elon Musk can use whatever name he wants, but according to information from Chinese suppliers, Tesla has been asking them to provide components for this vehicle since September. The documentation indicates that this will be a hatchback. In the past, when rumors surfaced about Tesla launching the Model Y standard, reports from Chinese suppliers revealed similar details, and that eventually turned out to be true. Because of that, there's a strong chance the Model 2 will be a compact hatchback, smaller than the Model 3 and Model Y, introducing a design language that has never appeared in Tesla's lineup before. And yes, Tesla doesn't currently have any hatchbacks. Its portfolio so far has been dominated by sedans and SUVs. Elon Musk has only revealed that the vehicle will be heavily simplified, but it won't copy any existing designs. This means it won't look like the Model Y or the Model 3 we're familiar with. It seems Tesla doesn't want to create a simple mini version, but rather a product with its own personality, distinct enough to stand on its own. In other words, the Model 2 is being positioned as a completely new hatchback. Smaller, simpler, built with more cost-efficient materials, and priced at around $30,000, which makes this strategy more logical than ever. Above all, Tesla has a dedicated battery technology to make this price point possible, and surprisingly, it's a battery that can be considered quite powerful. Yes, CATL, the leading Chinese battery manufacturer and Tesla's partner for supplying batteries for this new model, has stated that Tesla's next affordable vehicle will be the first to use its Shenzhou 2 battery. This is a low-cost LFP battery, but its performance is anything but insignificant. According to the company, this battery delivers unprecedented charging speeds and driving range. It meets the expectations for affordable vehicles while still providing reliable performance. Initially, Tesla planned to use a conventional LFP battery for this model, but testing results reportedly fell short of expectations, making Shenzhou 2 a surprisingly strong alternative. So what makes this battery special enough for Tesla to choose it? Okay, CATL has actually been researching this battery for many years, and it has gone through multiple generations to achieve both optimal performance and maximum cost efficiency. As many of us know, especially those who follow battery technology, LFP batteries have several major advantages. Tesla itself has used LFP batteries for a long time in the Model Y and Model 3. They're safe, durable, and affordable. However, their biggest drawbacks have always been lower energy density and slower charging speeds. That said, Shenzhou 2 significantly improves both energy density and charging speed, allowing Tesla's new model to achieve long driving range along with impressive charging performance. CATL claims this is the world's first LFP battery, capable of delivering close to a 500-mile range while supporting ultra-fast 12C charging. The system can add about 47 miles of range in just 30 seconds, roughly 1.55 miles per second, and can reach over 320 miles of range with only 5 minutes of charging. Oh my God, that's almost unbelievable, right? It's arguably more powerful than any battery technology we've heard of so far. But that's not all. This battery also delivers remarkable performance in cold weather, which is a major advantage for electric vehicles. CATL reports that the battery can charge from 5% to 80% in just 15 minutes at 14 degrees Fahrenheit, which is more than 100% better than the current industry benchmark. Okay, essentially, this is the most powerful LFP battery we've ever seen, and with this technology, the Model 2 should achieve at least a 320-mile range. Thanks to its fast charging capability, Tesla may even reduce the battery pack size to around 50 kilowatt-hours to optimize costs. So, in short, we can realistically expect a new $30,000 Tesla that still delivers around 300 miles of range, something most other vehicles struggle to achieve. If you know of any car under $30,000 that can still hit 300 miles of EPA-rated range, let us know in the comments below. Despite being priced even lower than the Model Y standard, the Model 2 appears to meet and in some cases even exceed the expectations of many customers. The front-end design is rumored to be almost completely different from previous Tesla models. While the Model 2 won't feature a front light bar, it is expected to have sharper, more aggressive headlights. Some leaks suggest the headlights will be fairly similar to those on the Model 3, though with less powerful illumination. From a design standpoint alone, however, it clearly looks better than the Model Y standard. As a hatchback, the Model 2 will be easy to distinguish from other Teslas and will be significantly smaller than the Model Y. But interestingly, this apparent drawback actually becomes an advantage during manufacturing. With the latest generation of gigacasting technology, Tesla can essentially cast the entire body structure as a single unified piece, something it hasn't been able to fully achieve with the Model Y or Model 3. This is also one of the key secrets to bringing the price of this model below $30,000. By eliminating a large number of unnecessary joints and gaps, the vehicle achieves an extremely clean, seamless appearance without sacrificing its modern look. Simply put, the smaller the car, the faster the casting process, since there are fewer components involved. That's why Elon Musk has hinted that this will be a vehicle that can be produced very quickly on the Fremont production line.
The fastest production ramp of any product, of any large complex manufactured product ever.
At one point, many people believed this model would inherit bold door mechanisms such as falcon wing doors, or at least a unique solution similar to the Cybercab. That assumption made sense, since the Cybercab was once rumored to be a twin sibling of this vehicle. However, those expectations were quickly shut down. Unlike the Cybercab, which is built around the groundbreaking unboxed manufacturing process, the Model 2 is being developed with a more cautious approach, continuing to use a familiar assembly line in order to optimize costs and enable true mass production. As a result, Tesla made a smarter choice for the Model 2. Instead of chasing flashy door mechanisms, it focused on refining what already works. The car retains a traditional four-door layout, but everything has been re-engineered, from the hinges and panel gaps to the opening angles, to better suit everyday use. This isn't just a design decision, it's a practical one. Falcon wing doors may look visually striking, but they come with added complexity, higher costs, and greater space requirements. For a vehicle aimed at the mass market, Tesla clearly understands that usability and efficiency matter far more than visual flair. Another feature on the Model 2 that will excite many people is that it still comes equipped with a front bumper camera, seamlessly integrated into the overall design. This shows that Tesla doesn't treat autonomous driving technology as an optional extra, but as a core pillar of its brand identity. That's why, even as a lower-priced model, the Model 2 still fits into Tesla's long-term strategy. Model 2 owners may be able to enroll their vehicles in Tesla's Robotaxi service when they're not using them, potentially allowing them to earn additional income. Inside this model, Tesla is rumored to significantly cut back on cabin features, something that may turn off some customers, or at least require a period of adjustment. The interior of the Model 2 is being designed around one very clear goal: minimizing costs without losing the core Tesla experience. The central infotainment screen is expected to shrink to around 10.5 to 11 inches, small enough to save money compared to the 15-inch display, yet still capable of delivering the same fast processing, smooth interface, and familiar voice control found in higher-end Teslas. The most controversial change may be the control layout. According to rumors, the Model 2 could continue Tesla's move away from traditional stalks and gear selectors, similar to the refreshed Model 3, replacing them with a minimalist driving interface that relies on capacitive touch zones on the steering wheel. For older users, this could be an initial barrier. However, from Tesla's perspective, eliminating mechanical components not only reduces costs, but also lowers long-term failure points and significantly shortens assembly time. Other interior cutbacks follow the same philosophy. The seats are reportedly upholstered in fabric instead of vegan leather, resulting in a less premium feel and more difficult cleaning. Heated seats are said to be omitted, and the panoramic glass roof is removed, making the cabin feel less airy. Single-pane acoustic glass and a simplified speaker system will likely impact both noise insulation and the overall audio experience. Ambient lighting is also reduced to a single color, functional, but not designed to feel luxurious. Elon Musk has been very clear about this. If you're looking for premium features and a more refined driving experience, Tesla already offers other models for you. The company's lineup needs clear segmentation, and the Model 2, without a doubt, has been built to prioritize affordability and mass accessibility above everything else. Initially, Elon Musk revealed that this model would be produced at Giga, Texas. But it appears that the focus on Cybercab production has pushed the project to Fremont instead. Interestingly, Fremont turns out to be a very natural fit for building this vehicle. Yes, Tesla's Fremont factory is widely considered an ideal location for producing the Model 2, because it brings together all the elements needed for a strategic, low-cost vehicle that still incorporates new technologies. First of all, Fremont is Tesla's oldest factory and effectively serves as a living manufacturing laboratory, where the company frequently tests, refines, and perfects new technologies before rolling them out to other factories. As we mentioned earlier, the Model 2 is expected to adopt several major innovations, including next-generation gigacasting structures, a drastically reduced parts count, new materials, and even a completely different battery technology. Producing the car at Fremont allows Tesla to better control risks and make rapid adjustments if issues arise. In addition, Fremont has extensive experience building small and mid-size vehicles like the Model 3, which shares a design philosophy and assembly process much closer to the Model 2 than factories that specialize in SUVs or pickup trucks, such as the Texas plant. Fremont's location near Tesla's R&D, AI, and autopilot centers in California also enables close collaboration between design, software, and manufacturing teams, shortening debugging cycles and accelerating overall product optimization. Okay, we also believe that producing the Model 2 in the US allows Tesla to take advantage of domestic manufacturing incentives, reduce geopolitical risks, and build the image of an affordable made-in-USA electric vehicle for the domestic market. More importantly, although labor costs at Fremont are relatively high, Tesla offsets this with deep manufacturing experience, low defect rates, and exceptional process optimization, which helps lower the cost per vehicle. The year 2025 could be considered a fairly lackluster one for Tesla, as vehicle sales declined noticeably due to the company's inability to launch a product that truly matched the expectations of the broader market. After a period of explosive growth, Tesla's product lineup began to show signs of stagnation. The Model S and Model X appeal to a very narrow audience. The refreshed Model 3, while improved, was not new enough to create a major breakthrough, and the Cybertruck is simply too niche, too expensive, and not aligned with mainstream tastes. In that context, the Model Y Standard was supposed to be a sales lifeline, but in reality, it turned out to be a somewhat misguided move. The biggest problem with the Model Y Standard is that it was stripped down too much without becoming cheap enough. The use of a lower capacity battery limited driving range, while the price, despite the feature cuts, was still not attractive enough to create a clear advantage over competitors, especially Chinese EVs and increasingly popular hybrid models. For many customers, the Model Y Standard ended up in an awkward middle ground. Not affordable enough to be an economical choice, yet not good enough in terms of range and features to justify spending more. As a result, many buyers delayed their purchase or switched to other brands. More importantly, the Model Y Standard failed to address Tesla's core challenge in 2025, the lack of a truly new, affordable vehicle designed from the ground up for the mass market. Instead of delivering a product that was genuinely disruptive in terms of price and user experience, Tesla merely adjusted an existing model by cutting features, creating a sense of regression rather than innovation. That's why the Model Y Standard not only fell short of boosting sales as expected, but also highlighted the market's urgent demand for a truly new vehicle, a role that many believe the Model 2 will need to fulfill in the next phase. The Model 2 is expected to be a major turning point for Tesla, and it will most likely be revealed in the second quarter of next year. What do you think about this car? Would you buy it? Drop a comment below. Okay, what would happen if one day you found yourself standing in the middle of the desert, your car still fully intact, the battery not dead, but your phone had absolutely no signal, and the outside world had no idea where you were? It sounds like a movie scenario, but in reality, this has happened many times. And it's precisely in situations like these that we believe in. Car internet connectivity is no longer a luxury. It's gradually becoming a matter of survival. Tesla seems to have recognized this as well, quietly filing a patent to integrate Starlink directly into its vehicles. This isn't just a technological leap. It's a sign that an entirely new game is being opened up for the global automotive industry. So, why is Starlink in Tesla's a fantastic idea? Let's find out right now. Electrek was the first to report that Tesla is preparing to integrate Starlink into its vehicles, both new models and existing ones. Honestly, this rumor has been circulating for years, and Elon Musk has hinted at this combination multiple times. As soon as the report came out, it didn't take long to realize that this would be a major advantage for Tesla customers, and it could be a big enough upgrade to convince me to switch to a Tesla. For many years, in-car internet was mainly used for navigation, music streaming, or software updates. But with Tesla, connectivity is the backbone of the entire ecosystem. From autopilot and data collection to OTA updates and even using your phone as a car key. We've seen plenty of situations where losing internet for just a few minutes caused real problems for users. Being unable to unlock the car, failing to sync data, or even being unable to continue a trip. This makes one thing very clear. The smarter the car, the more it depends on connectivity, and the problem is that traditional cellular networks were never designed to cover the entire planet. In the US, Europe, or Australia, there are still vast areas with absolutely no signal at all, and in Australia alone, more than 50% of the mainland has no mobile coverage whatsoever, even from the best carriers. When you enter those regions, even the most advanced smartphone becomes useless. We believe this is the fatal weakness of the current connectivity model, and that's exactly where Starlink enters the game. Not everyone fully understands Starlink. Unlike terrestrial networks, Starlink is a constellation of thousands of low Earth orbit satellites that cover nearly the entire globe. This means that anywhere you can see the sky, you can still have internet. Tesla isn't simply adding a satellite antenna. Its patents reveal a deeper approach, redesigning the vehicle's roof using RF transparent materials that allow satellite signals to pass through with minimal loss. Yeah, Tesla has filed a patent application for a vehicle roof component that is transparent to radio frequencies, specifically noting that it allows satellite signals to pass through. This is crucial, because as far as we know, signals from SpaceX satellites cannot reliably penetrate glass or metal. Okay, this solution directly tackles a very difficult engineering problem. The traditional glass and metal used in car construction are major barriers to satellite signals. Integrating the antenna directly into the roof structure not only provides more stable connectivity, but also preserves aesthetics, eliminating the need for bulky external hardware. This shows that Tesla isn't experimenting just for fun, it's preparing for a new connectivity standard in automobiles. And if Starlink is truly integrated directly into Tesla vehicles, the advantage the company gains won't be limited to internet speed. It will be about near-continuous connectivity almost anywhere on Earth, more reliable transmission of autopilot data, software updates that no longer depend on patchy cellular coverage, a smoother entertainment experience on long journeys, and most importantly, enhanced safety in emergency situations. More importantly, what if Tesla allowed you to use the Starlink signal as a mobile hotspot? In other words, you'd be able to share that data with any device. Okay, that's a big assumption. Tesla is one of the few companies that doesn't allow you to use its vehicles as mobile hotspots, but the potential benefits could be enormous. Tesla vehicles already have an excellent camp mode that lets you run the climate control, watch movies, charge electronic devices, and use the lights without worrying about the 12-volt battery. Add an internet connection, and you suddenly have a fully functional remote office and sleeping space available anywhere in the world, as long as you're within a few hundred miles of a power outlet. Obviously, this would be especially beneficial for the Cybertruck, which has the tires and ground clearance to venture deep into remote areas, along with the power output needed to run a mobile office. Of course, there's a downside. Internet everywhere all the time means you can be reached anywhere. A camping trip is no longer an excuse to avoid checking email. You'll still get work notifications from the very thing you're trying to escape. But in our opinion, the benefits would be well worth it. We believe that in the near future, consumers will start asking whether a car has satellite connectivity in the same way they once asked about airbags or ABS braking systems. Because this is no longer a question of comfort, but of survival. In reality, there have been many cases where drivers have died after getting lost, stuck, running out of fuel, or being involved in accidents in areas with no cellular coverage. They couldn't call for help, couldn't send their location, and no one knew they were in trouble. If a vehicle were equipped with satellite internet, a single emergency signal could allow their location to be identified almost immediately. In those life or death moments, just a few minutes of connectivity can be the line between living and dying. You see what we mean, right? So with this plan from Elon Musk, we believe the greatest value of integrating Starlink into cars lies in its human impact. For people who love long road trips, off-grid camping, or exploring remote places, Starlink in a vehicle isn't just a convenience, it's freedom. It allows them to work, communicate, navigate, and stay entertained anywhere without worrying about coverage. It's no surprise that some Tesla owners have already installed Starlink mini systems on their own. But when this technology is integrated directly by the manufacturer, the experience will be entirely different, cleaner, more reliable, and far safer. From another perspective, we believe that if other automakers don't move quickly to adopt Starlink or equivalent solutions, they'll soon find themselves on the back foot as consumer expectations shift. Tesla has the advantage because it acted early, but this game is still wide open, and the real question is who will dare to step in next. That's because Tesla isn't just selling electric cars. It's selling a vision of mobility that is always connected, always updated, and always safe. And it's very possible that when we look back, we'll realize that the moment Tesla brought satellite internet into cars was the point when the automotive industry entered a new era, one where connectivity is no longer limited by the ground. At that point, the question won't be whether you need Starlink in your car, but whether you dare to drive without it. As we made clear earlier, Starlink is a high-bandwidth, low-latency internet system capable of supporting the volume of data Tesla vehicles consume, while delivering a far superior experience compared to cars without this technology. This will undoubtedly be a major advantage for Elon Musk in selling more vehicles than Tesla's competitors. In reality, we've already seen some Tesla owners actually using Starlink mini dishes inside their vehicles for off-grid camping or traveling between remote locations. But this time, Starlink would be integrated directly into the vehicle, and we believe that would completely elevate the user experience. Tesla also tends to roll out new technologies quite quickly, so it may not be long before we get to experience this feature ourselves. We've also learned that Brazil has banned Starlink, and China has done the same. Why did they do that? Do they have something they want to hide? Clearly, banning the internet is not a good thing. Do you know more about this? Let us know in the comments below. More importantly, how do you feel about Tesla vehicles having Starlink? Shifting to the latest developments around the Cybercab, Tesla is accelerating efforts to bring this two-seat autonomous vehicle into real-world operation. Over the past week, social media has been flooded with images and videos showing the Cybercab beginning to operate in real-life conditions, drawing significant attention from the tech and EV communities. These are some of the rare instances we've seen the vehicle driving on public roads since the event last October. Most recently, in downtown Austin, a rather unusual Cybercab was spotted undergoing real-world testing with a safety supervisor sitting in the driver's seat. The vehicle, bearing Texas manufacturer plates and finished in Tesla's distinctive matte gold paint, was photographed driving through downtown Austin traffic. However, unlike earlier prototypes we've seen which had no side mirrors, this test vehicle was equipped with a pair of small side mirrors and even a steering wheel. Okay, Elon Musk has repeatedly stated that the Cybercab is designed to have no steering wheel or pedals, just two seats and no driver inside. Some reports suggest that the temporary triangular side mirrors mounted on the Cybercab are intended to ensure compliance with federal motor vehicle safety standards, which require side mirrors on vehicles that are operated by a human driver. While the current camera angles don't clearly confirm the presence of a steering wheel, the appearance of a safety display in the front seating area along with side mirrors strongly suggests that Tesla is using the Cybercab as a test prototype for safety evaluation and regulatory compliance before entering mass production. In fact, fitting a temporary steering wheel is nothing new. The Cybercab has previously been spotted testing at Giga Texas with an added steering wheel for development purposes. So if this latest vehicle is using a similar approach, it's a familiar and reasonable step in Tesla's development roadmap, rather than an unexpected twist. Recently, we've seen Model Y robotaxis operating fully driverless on the streets of Austin, which has led many people to ask, if Tesla can already do that, why does the Cybercab still need a safety supervisor? The answer comes down to two key factors. The first is regulatory barriers. Although the Cybercab is designed from the ground up to have no steering wheel or pedals, current federal motor vehicle safety standards still require any vehicle operating on public roads to be equipped with manual controls and side mirrors. Tesla is actively working with regulators to establish a dedicated federal framework for autonomous taxis, which would eliminate components that are no longer necessary in the self-driving era. However, at this stage, technical test vehicles are still required to comply with these regulations. The second factor relates to data collection and experience optimization. Placing an engineer on board isn't just about monitoring edge cases, it's also about capturing real-world data while testing the system's operational limits. Qualitative feedback on how the vehicle behaves, how the ride feels, and overall comfort from an engineer's perspective will be critical in helping Tesla fine-tune the Cybercab so that future rides are not only safe, but also smooth and comfortable for passengers. This isn't the first time a Tesla engineering test prototype has appeared in public. However, the fact that the Cybercab was spotted weaving through downtown traffic rather than being tested in a controlled environment at Giga Texas carries a very different meaning. It shows that Tesla has entered a new phase of real-world validation, where the vehicle is not only being tested technically, but also being stress-tested in the complex conditions of urban traffic. Even more notably, with Cybercab mass production currently targeted for April 2026, now just about 4 months away, Tesla's teams are clearly racing against the clock. The goal is not only to finalize the technology, but also to prepare Cybercab for real-world deployment, gradually replacing the Model Y robotaxi fleet on the streets of Austin and the San Francisco Bay Area. If everything stays on schedule, this could mark the next major turning point in Tesla's robotaxi strategy. While robotaxi vehicles are steadily convincing the public that fully autonomous cars can operate on city streets, Optimus has raised quite a few questions in recent months. An incident involving Optimus version 2.5 falling over and suspicions that it was being remotely controlled has led some to doubt the robot's true level of autonomy. With Robotaxi, Tesla has more than a decade of data accumulated from millions of vehicles driving every day. Every brake application, every steering input, and every traffic scenario becomes training data for the full self-driving system. The public may be skeptical, but they can also see a clear trajectory. The cars are getting smoother, and their behavior is becoming increasingly human-like. By contrast, Optimus feels like far too big of a leap. There are no millions of humanoid robots operating in the real world to collect data. There's no standardized environment like traffic lanes or road signs. Every step, every doorway, every object in a factory or a home is different. That makes the expectations placed on Optimus both enormous and fragile. The incident in which Optimus version 2.5 fell during a demonstration became the last straw for many people following the project. The video spread rapidly on social media, accompanied by sarcastic comments like, "A self-driving robot that falls like that?" Or, "Is this AI or just a high-tech puppet?" More notably, some observers suggested that Optimus's movements in demos showed signs of remote control rather than full autonomy. Although Tesla hasn't released enough technical detail to fully silence these doubts, the relative silence has only fueled more questions from the public. Is Optimus truly autonomous, or is it still only semi-autonomous, heavily dependent on humans behind the scenes? However, if we look at the issue more fairly, we have to acknowledge that a humanoid robot falling over is not all that unusual during development. Even humans need many years to learn how to walk steadily, let alone a machine that must learn to balance on two legs and coordinate dozens of joints in real time. The truth is, the problem isn't the fall itself, but the expectations the public has placed on Optimus. When Tesla unveiled the robot, the message was extremely bold: a general-purpose robot capable of working in factories, helping at home, and replacing humans in dangerous or monotonous jobs. Those promises naturally led people to compare Optimus to sci-fi robots, machines that move smoothly, react flawlessly, and rarely make mistakes. In reality, Optimus is still very much a product in the early stages of its evolution. The suspicion of remote control also deserves a calm, rational look. In robotics, the use of remote control or teleoperation during the training phase is extremely common. Humans can guide the robot through specific movements, allowing the system to learn motion trajectories, applied forces, and joint coordination. Yeah, and that doesn't mean the robot is pretending to be autonomous. The issue lies in how Tesla communicates. When a demo is presented as if the robot is fully autonomous, while in reality there may still be some level of remote assistance, the gap between expectation and reality quickly turns into skepticism, and that understandably frustrates people. Comparing Optimus with Robotaxi also highlights an important difference: society's tolerance for risk. Autonomous cars, controversial as they may be, still operate within a familiar framework: road traffic, where humans have centuries of experience managing risk. Humanoid robots are different. They touch on much deeper anxieties: job displacement, loss of employment, and the presence of an entity that looks human but isn't. As a result, any mistake Optimus makes is easily amplified into proof that AI isn't ready, or even that Tesla is exaggerating its technology. Even so, if we strip away the noise of social media and look at the technical core, Optimus still represents a very compelling direction. Tesla isn't building robots in the traditional way, machines designed for a single, narrowly defined task, but instead is aiming for a general-purpose platform capable of learning many different skills. This is a harder path and a slower one, but if successful, the value would far exceed that of a robot that can only repeat one job over and over. The fall of Optimus 2.5, or the suspicions around remote control, can be seen as inevitable scars along that journey. Ultimately, the biggest question isn't is Optimus fully autonomous yet, but is Tesla getting closer to that goal? With Robotaxi, the answer is becoming clearer over time through real-world data. With Optimus, the answer is still open. But that very skepticism may be the most important test of all. If Tesla can prove through more transparent updates and more convincing demonstrations that Optimus is genuinely learning and improving with each generation, today's doubts could become a footnote in the history of robotics. On the other hand, if the gap between promises and reality continues to widen, Optimus will face not just a technical challenge, but a crisis of trust. If it fails to convince people of its usefulness as Elon Musk repeatedly claims, it's unlikely anyone will want to buy an Optimus. What do you think about Tesla bringing Starlink to its vehicles? Are you excited about Robotaxi being widely deployed? And finally, what about the Tesla bot makes you skeptical? Let us know your thoughts in the comments below. Thanks for watching.